Assalamualaikum warahmatullahi wabarakatuh. My name is National Maintenance. My project number is CE 200. So today for the introduction for this project, the first one is the invention of integrated circuit IC has allowed computers to evolve from enormous machine to compact notebooks. Second, with their connection, various active and passive elements can be put using integrated circuit on a small silicon wafer. Third, epitaxial growth, masking impurity diffusion, oxide growth, and oxide etching are some of the procedures used in fabrication of integrated circuit, with photolithography being used to create the patterns. Number 4, the most complicated part of integrated circuit IC, transistors are available in a variety of forms, including CMOS, BJT, and FET, which are chosen based on particular requirement. The last one is this project objectives are to offer a commercial innovation for a foundry plant based on microfabrication clean room tool and to show how professional ethics are applied in the creation and design of microfabrication process. CMOS is complementary metal oxide semiconductor. It combination of NMOS and PMOS transistors. The fabrication of CMOS can be done by 20 steps. CMOS can be obtained by integrating both the NMOS and PMOS transistor on the same chip substrate. The fabrication of CMOS is described using the P substrate. The NMOS transistor is fabricated on a P-type substrate and the PMOS transistor is fabricated in N-web.
Hi, my name is Phoebe, and now I'll present on the setup cost for the project. So, setup cost refers to the expenses incurred in the process of preparing a production or manufacturing system to produce a specific product or a batch of products. These costs are primarily incurred to ensure that production system is ready and optimized for the new product or batch, thereby maximizing efficiency and minimizing downtime. First is the labor cost, which is the expenses related to the wages and salaries of the workers involved in the setup process, such as machine operators, technicians, or maintenance personnel. The second one will be the material cost, which is included with the expenses for the materials needed for the setup, such as raw materials, components, lubricants, and cleaning agents. And the third one will be the equipment cost, which is associated with the use of specialized tools, machinery, or instrument required for the setup, including any rental fees, depreciation, or maintenance expenses. And the last is the downtime cost, which is due to the interruption of production during the setup process, including the loss of potential revenue or productivity. For our project, the design and engineering setup cost will be around 100,000, which includes the engineer and designer team, salaries, software licenses, and design tools. As for the mask creation, the company will have the contracts with specialized mask making companies to produce required masks, which will require 50,000. And then moving on to wafer fabrication, which is a semiconductor fabrication facilities, chemicals, and energy consumption labor will be included with this cost, which is around 500,000. And last but not least is the testing and quality control, which uses about 75,000, which includes the technician, electrical testing, and quality control. The total setup cost needed for this project is 725,000.
by Muhammad Nasir, and my matrix number is CA200173. So today I will present about the fabrication process. This is the process to fabricate the CMOS transistor. So first, oxidations, photoresist, photolithography, etching, strip photoresist, and well formations, strip oxide, polysilicon patterning, self-align, and diffusions, p-diffusion, contacts, and last one is materializations. So we will see to the more detail about the designing and step of fabricate the process. So coming to the first step is to the selections of the substrate. We use an annual process definitely to consider the P substrate. This is the base material for designing a transistor. Start with the blank wafer. The next process of fabrication is oxidations. Here we use silicon dioxide within the thickness 1 micrometer, and the entire surface of the P substrate and metal is SiO2. The main purpose of doing this is to protect the surface of the silicon vapor. Next, third step process is depositing of the photoresist. This process light sensitive. Two type of the photoresist, that is positive and negative. Positive resist can be removed if exposed to the UV light, while the negative resist cannot be removed if exposed to the UV light. Next, fourth steps process is photolithography. Simply we passing some UV light to expose photoresist to ultraviolet light through the end-well mask. Using some mask, and we want to be place the end-well. Next, for the step 5 process is etching. Remove with the help chemicals, that is hydrofluoric acid, only attack the oxide where has been exposed. For the step 6 process is strip photoresist. The remaining photoresist will be stripped off. Next, for the step 7 process is end-well formations. Diffusion process will be used to make the end-well on the right side of the wafer, but we also can use the ion implementations process to create end-well. So next for the step 8 process is strip oxide. Remaining the oxides on the surface of the wafer will be stripped off using hydrofluoric acid. Oxide need to be removed to create a gate junctions. A very thin layer of the gate outside is deposit, as is polysilicon. We will use the CVD, that is chemical vapor depositions of the silicon layer is used to be form the polysilicon. Next, for the step 10 process is polysilicon patternings. So lithography process is apply again to pattern the polysilicon. Tiny gate oxide and the photoresist is applied again on the wafer to protect two gate terminal. So that's all from me. I will pass to the next presenter. Thank you.
Now I will explain about self-align process. As we know, in fabrication, end-well is created in P substrate and it formed with diffusion or ion implantation. Referred in the figure, oxide and masking are used to expose where N+ dopant should be diffused or implanted. NMOS source, drain, and end-well contact are formed by N diffusion. As we can see in the figure, oxide is patterned and N+ region is formed. Then, oxide is stripped off to complete the patterning step. Next, this process is create the contact. For P+ diffusion region, for PMOS source and drain are formed along with substrate contact. Then, the chip is covered with thick field oxide. The oxide is then etched where contact cuts are needed. And lastly, for step of CMOS transistor, as we can see from the figure, it is show the source and drain for N plus region and P plus region. For metallization process, it is patterned to remove axial metal and leaving the wires. In conclusion, the integrated circuit is widely used in computer technology. The development of active and passive element on small silicon wafer enable the miniaturization of electronic devices. It involves complex steps such as epitaxial growth, impurity diffusion, and photolithography to create complex structures on small silicon wafer. The process requires careful design, adherence to professional ethics, and significant setup costs, when it's crucial for improving technology. That's all from us. Thank you.